What we're going to talk about in this video is the concept of a stack. It's a data structure that's very popular in computer science. It's used quite a bit. In fact, a stack is built into the CPU, the instructions in a basic CPU. Every CPU that I've ever encountered has operations that support stacks. And basically, there are two operations that you perform on a stack. They're basically the push operation and the pop operation. Push means you're putting something on the stack. Pop means you remove something from the stack. So there's pushing and popping. And the concept of a stack is basically a last in, first out data structure. Okay? And so when you have such a data structure, and we've all encountered stacks in our lifetimes, and not even in programming. If you go to a cafeteria, they give you a pile of trays. And what happens is the tray that you remove, so pretend this was a stack of trays over here. You're not going to go on the bottom, most people don't anyway, and take the tray that's in the middle. You take the tray that's up top, and you pop that tray off the stack. In terms of a computer, we basically perform this operation last in first out when you execute code. Like you have your main method. Here's your main method that's executing. All right, and there's a bunch of local variables here. All right, and then there's a statement in your main method that calls a method A. Well, okay, you're gonna go to method A. Here's method A, and the A has its own little local variables that it works with, and then A calls another method B. Okay, so it has its own little local variables. Now all these local variables are what are called on the stack. They're still there even though B executes. B executes its code. Okay, so basically A main goes to A, means it pushes the information on the, whatever's in main, information gets pushed on the stack so it can go on to A. A does its thing and executes B. Okay, these are called stack frames over here. These local variables are in stack frames. A calls B. B does its thing. B doesn't call anything. Pretend B doesn't call anything. It finishes. It returns. Well, where do you think it's going to return to? It's not going to go back to main. It's going to go back to the statement after the statement that called B, which is an A. So what happens is you're going to pop off the stack the information required to go back to A, and A continues its operation. Meanwhile, these variables here are gone. They're no longer there. A continues and finishes and returns, and where's it going to go? It's going to go to the statement that is right after the statement that called A back in main. So you come back here. So what you're doing is you're popping, once you return from these methods, you're popping the information necessary to go back to the method that brought you to A, brought you to B. So you're familiar with that operation. But I don't know if we've ever discussed the concept of stacks in that operation. Okay, there's actual in the CPU they actually have commands push, and pop. Those commands there perform the operations that I described. Now, that's one example. Then there's another example I like to talk about, and that is, let me clear this out. File, new. Okay, let's clear this. We can close this. We can get rid of this. Don't save this. What's called reverse Polish notation. This is a classic example of using a stack. Now, with reverse Polish notation, pretend I had this statement right here. 4 times parentheses 5 minus parentheses 7 plus 2. Okay, nothing major, nothing serious here. This is the type of expression that you're familiar with because, 7 plus 2, the operator is in between the operands. They call this an infix notation. And you're familiar with infix notation. All right. And you're also familiar with the order of operations because they taught you that. You have to do your multiplications and divisions before you do your additions and subtractions. And everything is done in left to right order. Well, it turns out that this expression here is really sort of complicated to perform because you have those rules. You have parentheses have to be done first, you have your order of operations, and then you have to go left to right order. Now, we can convert this expression to what's called reverse Polish notation, and let me just jot it down. The idea is you take the order of your operands and you list the order of operands in that order. In this case, this is what you have here. This is the reverse Polish notation. Postfix, they call it. Postfix. So postfix and reverse Polish notation means the same thing. Just understand that. Now, this is very, very easy for a computer to evaluate. Okay? You need one stack. Okay, you need one stack. And then what you're going to do is anytime you have an operand, like 4, 5, 7, 2, you push them on the stack. Operands automatically get pushed on the stack. So 4 gets pushed, 5 gets pushed, 7 gets pushed, 2 gets pushed. Okay? Then what happens is you have an operator. Now, an operator blindly just pops off 2 things on the stack. So the thing that we're going to pop off is the 2 and the 7. Let me get my eraser here. I got my little eraser. I'm going to pop off the 2 and the 7. Okay, so I'm erasing those. They're popped off the stack. Okay, so I have the 2 and the 7. And when you pop them off, the thing that gets popped off is the right-hand side first, and then the left-hand side gets first. We perform this operation plus, that gives you the value of 9, and then you're going to push that 9 on the stack. Okay, so you're going to do that. So let's cancel that out. Next token that we encounter is a minus sign, and a minus sign is a operator. And operators basically do this. You pop 2 things off the stack. You pop off the 9, that's the right hand side. You pop off the 5, the left hand side. You perform the operation. So 5 minus 9 is -4. And then we push the -4 on the stack. Now, once we remove, we really should have erased these 2 things, okay, because we popped them off the stack. Okay, they're being erased right there. They're not on the stack. And then what we're going to do is push the -4 on the stack. So that's the state of the stack. And then we do a multiplication, which means that we're going to pop out. Let's get rid of this calculation too. And we're going to put, this is an operation minus. Minus means we're going to pop off the -4. That's the right-hand side. The 4 is the left-hand side. We're going to perform that operation. And then that's going to give you the answer of -16 as the answer. So what's going to happen now is we're going to erase those things that we popped off the stack. And then we're going to push the -16 on the stack. And since there's no more tokens there, you're done. The answer is -16. If there's one thing on the stack, if there's got to be one answer on the stack, and that one answer is the result of this operation. Okay, now you understand that with reverse Polish notation, with postfix, you don't need any parentheses. Okay, you really don't even need the order of operations. The order in which these operands are performed is the order of operation. Let me give you one more example. Let me clear this. Edit, undo drawing. Let's see, file new. Okay, let's close this guy right here. Don't save that. Let's go ahead and just do one more example. How about this one here, where I'm going to give you the infix version. 5 plus 7. We're going to perform that. Then we have times 6 minus 2. Okay. We'll have ourselves a little stack here, ready to do the operation. Now first, this is infix. We need to convert that to postfix. Very, very simple. Okay. And the key to going from infix to postfix is make sure you do the operands in that order. 5. You're going to do the 5. You're going to do the 7. Then you're going to add those two together. Then you're going to push a 6, and then a 2, minus, and then times. Okay, that's the infix representation of this. Okay. What happens now? We're going to evaluate this expression. 5, it's a token 5. That's an operand. Push it on the stack. Operands just automatically get pushed on the stack. 7. Okay, plus. Plus is an operator. Pop two things off. The 7 and the 5. Add them together to give you 12. And we're going to erase what we popped off the stack, of course. That's gone. And I'm going to push back on the stack the 12. Okay. 6 gets pushed. 2 gets pushed. Minus. Okay. Well, that operation down here got done. So we do a minus. We pop off the 2. We pop off the 6. Do the minus, which is 4. And we're going to push the 4 on the stack, but after we remove the 6 and the 2. And then 4 gets put on the stack. And we perform that operation. Then the last thing that we do is a multiplication. We pop off the 4. We pop off the 12. There's your multiplication. That's 48. And then we erase the two numbers here. It's not a very good eraser, but you get the idea. 48. And if there's one number in the stack, you're done. See, we've evaluated all these tokens. We're done with that line. There's only one number, 48. There you go. Now, you could have, if you forget an operator, you might end up having, like, say we forget the times. Pretend it wasn't there. We have the minus. Okay, what's going to happen is, I believe, this is the state of the, yeah, this is what happened. Before the 48, we had 4 and 12. But pretend we didn't have the minus. Now, if we didn't have the minus, we'd have two things on the stack. And when you have two things on the stack, that means that you have an illegal expression. Okay, it's as if you wrote this without the times originally in there. That doesn't make any sense if there was no times there. So you need to make sure you only have one thing on the stack. You can't have two or three things on the stack because that's illegal. And you could also have the situation where you do something like this. 5 plus 6, 7 minus. Okay, push the 5 on the stack. Okay, plus, pop two things. You pop the 5, but then you have an empty stack, and you can't pop an empty stack. If you attempt to pop an empty stack, you have an illegal reverse Polish notation expression. You can't do it. So reverse Polish notation is a simple concept. It's not something that's very difficult. So you could, and I think it's something you need to know about. And so I've given you examples. So the next video I'm going to discuss, this all hinges on how do you implement a stack. Everything here, I have this little tube, and I can go ahead and erase and put something inside the tube. But how do you make that tube? Okay, that's going to be the implementation of a stack, and we'll talk about that in the next video. And let's leave it at that. We'll talk about it in the next video. Okay, take care.